Okay, in concept 1E, we look at the prime factorization, which is a method to express a composite number as a product of its prime factor. Okay, so why do we do this? It shows us the basic building block of a number, and because every whole number greater than 1 has its own unique prime factorization. So then why do we want to know this? Is because number one, it helps us to find the HCF and LCM, highest common factor and lowest common multiple, which we'll be learning about later on in the later part. Okay, and next, it also helps us to determine whether a number is a perfect square, perfect cube, or a power of a prime. Okay, so it is a systematic way to analyze and work with numbers. So how do we do this? There are two methods. Number one is the factor tree, which is not as which is not my preferred way to prime factorize. But what you do is think of it as you're dividing you're just breaking down the numbers into smaller pairs of numbers until all the numbers are prime. So let's say 40, I can divide it by 4 and I'll get 10. 4 can be broken down into 2 times 2 then, and 2's are prime numbers. 10 can be broken down to 2 and 5, and these are all prime numbers. So 40 is 2 times 2 times 2 times 5, and in index notation, there will be 2 cubed times 5. Okay, and it doesn't matter how you break it down. So for example, 40 can be also can also be broken down into 2 and 20. Okay, then 20 can be broken down into 2 and 10, or it can be broken down into 4 and 5 also. Then I'll get 2, 2 or 2, 5. Oops. Okay. Let me just. So regardless how you break it down, as long as you break it down into the simplest prime numbers, you will always get the same answer, which is 2 cubed times 5. Now, then the ladder method is very helpful because it will also be it can also be used in the later parts. Okay, but how do we use the ladder method? So we divide the numbers by the smallest possible prime numbers. Okay, so in exam, it is good to list down of the first few prime numbers so that it helps you to it gives you something to refer to, and so it reduces any possible panic. Okay, so 40, the smallest, can it be divisible by 2? Yes, it can. So 2, then I'll get 20. Divided by 2 again, I'll get 10. 2 again, I'll get 5, and then 5, and I'll get 1. So divide by prime numbers until 1 is obtained. So another example, 1188, it can be divided by 2. You'll get 594, 2, 297, 399, 333, 311, 11, 1. So 1188 equals to 2 square times 3 cube times 11. Okay, so this is how you get prime factors of 1188. And whenever in doubt, just make sure that you use your calculator to try all the different prime numbers. So for example, if I reach 297 and realize it is an even number, I'll just quickly, it is not an even number, so I'll just quickly choose the next prime number, and hey, just nice, it can be divided by the next prime number, which is 3. If it doesn't work, then I'll just divide by a bigger prime number, and bigger prime number.